Chapter 9, Section 4 is factoring to solve quadratic equations. So this is just a continuation of Section 3, the last section, where we were solving quadratic equations. But the issue now is, last section, we never had anything that had a b term. It was always ax squared plus c equals 0. We didn't ever have the b term. Where in this section, we will be introducing some polynomials that have that b term with them. And so the big property that you want to write down is called the zero product property, which is that if you have any real numbers a and b, and if those two numbers equal 0 when you multiply them, so if a times b equals 0, it has to be that either a equals 0 or b equals 0. It just makes sense, right? If that's the only way that that can happen. So now if you have two polynomials, like in this case two binomials being multiplied by each other, if they equal 0, one of these has to be 0. Excuse me, I had something in my throat there. So either this term has to be 0 or this term has to be 0. And so what we want to do is we want to take each one of those and set them equal to 0 and solve. Okay? So here's an example. If this binomial times this binomial equals 0, one of these two have to be equal to 0. And so let's find out what t values work to make this 0. Okay? So the first one, we're going to write 4t plus 1 equals 0. And then we're going to also set the second one equal to 0. And then we just solve. So 4t, let me take that back a step. We subtract 1 from each side. So we have 4t equals -1. Divide by 4, which gives us t equals -1/4. In this one, we would add 2 to both sides and get t equals 2. And so our answer is, our solutions are -4, -1/4, or 2. Now you can also write them using these curly brackets. It's called putting them in a set. Those are the solutions. And so think about this. If we plug -1/4 back in here, right here we get -1/4 minus 2, so that's -2 and 1/4. But over here, 4 times -1/4 is -1. -1 plus 1 is 0. And then 0 times what this equals 0. So that works. Or if we plug 2 in, over here we get 4 times 2 is 8, plus 1 we get 9. But over here we get 2 minus 2, which is 0. 9 times 0 is 0. And so that's how these are solutions. So again, what you're looking for is to take these binomial terms, set each one of them equal to 0, and finding out which numbers plugged in for x or t or whatever your variable is, give you 0. And now, what happens if it's not factored yet? Well, all that happens is that you have an extra step. And that step is that you have to factor this. So, thinking back, how do we factor that? We look for factors of 15. And we want factors of 15 where the sum is 8 right there. Okay? So factors of 15 are, we got 1 and 15, but I already know it's 3 and 5. 3 plus 5 is 8. So that's what we're looking for. Since this is 1, I can rewrite this as x plus 3 and x plus 5. equals 0. And now we're right back to where we have two binomials, and we take each one of them and set them equal to 0 and solve for x. So subtract 3 on both sides, subtract 5 on both sides. Here we get x equals -3. Here we get x equals -5. And so our solutions are -3 and -5. Oops. So just a little bit of an extra step that comes in on this one. Okay, let's try this one. Let's try C. Okay, so C has an A term other than 1. So we get factors of 2 times 18 is 36. We got 1 and 36, 2 and 18. 2 and 18, we're getting close. 2 and 18 is 20. 3 and 12. 3 and 12 is 15. I'm looking for -15. So -3 and -12 would work. -3 and -12 is still +36. That's -15. So that's what it is. Okay. Then we rewrite this. 2a squared minus 3a minus 12a plus 18. I'm just rewriting this. Box these off. Looking for GCF, I have a, so that's 2a minus 3. Here I'm going to, let's say, take out a -6. That is positive 2a. That is -3. And so our factors are 2a minus 3 and a minus 6. And then I take each one of these, 2a minus 3, and set it equal to 0, right? Because this is equal to 0, equal to 0. And I take a minus 6 equal to 0. Solve for this. And we get a equals 3/2. And over here we add 6 to both sides. And we get a equals 6. And so our solutions are 3/2 and 6. Okay. What about, say, something like E? E, what I want to do is get it in standard form first. So I want to subtract 16 from both sides. Now it's in standard form. And now I factor it. Well, I know that these are both perfect squares. This is 3b and this is 4. And so from our special cases, we know that it's going to factor to 3b plus 4 and 3b minus 4. And I take each one of these, set it equal to 0, subtract 4, 3b equals -4, divide by 3, I get b equals -4/3, and over here, add 4, divide by 3. So on this one, our solution would be -4/3 and +4/3. And so that is the only difference in finding solutions for a polynomial when the b term is present is you have to factor it. You can't just solve it using a square root, which we were able to in the first section. You have to factor it, set each factor equal to 0, and solve. Okay? Take a look at the book if you need a few more examples to look over, but this is what this section is about.